This is problem number 8 from section 5.3. It says a fossil contains 6% of the carbon-14 that the organism contained when it was alive. Graphically estimate its age. Use 5,700 years for the half-life of carbon-14. So, if we just kind of write out this function, we have y equals, and I'm assuming we're probably going to say y equals 100 for 100%, because I mean at some point in time it contained 100% of its carbon, right? So we're going to say y equals 100, and then our half-life would be 0.5 to the time divided by the 5,700 years. Now, if we can pull this exponential function up, this is what I'm using here to kind of piece through this. Now, it says at the end it had 6% of its carbon. So that's what the y value is going to be. It's going to be 0.06 equals 100. Or actually, we'll probably just use 6. So we'll say 6 equals 100, 0.5 to the t over 5,700. Now let's graph both of these, see what we come up with. When we graph them, we're going to use a graphing calculator. And we're going to go to y equals, clear out what we've got. So we're going to graph y equals 6. And we're going to graph 100, 0.5 to the x. And actually, we'll put this as a fraction. So x over 5,700. And then we're going to make our window, because of the percentage, I think our x value's got to be, our x value's got to range from, like, we're going to go negative 100,000 to 100,000. And then we'll go up by 1,000. Well, let's go up by 5,000. Our y value is the percentage. The y min is 0, and the y max is 100. Let's graph them. Okay, so we can see they're intersecting there. Let's go second, calc, find that intersection. That's the first curve. That's the second curve. Guess it. They're intersecting at, looks to be 23,135. So the time is going to be 23,135, and actually we might round up 36 years later. So that's how old that fossil is. That's a pretty old fossil.